Guess we're on. See what happens here. So, derivatives of the inverse trig functions. And you probably don't recognize this. These are this little test pattern from what they used to be on the TV screen when TV was actually off the air for certain hours of the day. You'd get up at whatever time, probably before 6 maybe, and this would be what would be showing on your screen. It's called the test pattern. So they didn't have TV 24 hours a day. Back when I was a kid, we didn't have TV, these newfangled things. But anyway, so that's the thing. They're all about patterns. That's the derivatives of the inverse trig functions. They're about the patterns. So there they are. They're also on your cards. What I want you to look at for a few seconds are what are the patterns that you see within the derivatives of the inverse trig functions. Stop for a second. I'll wait here. In fact, even if you don't pause, I'm going to put 30 seconds on the clock. I'm going to be totally silent for 30 seconds, starting now. You're supposed to be looking for patterns that you notice. You have 22 seconds left. I'm still being quiet, waiting. Don't fast forward. 10 seconds left. Patterns. See any? What'd you find out? Anybody notice the negative signs on this side? What do they all have in common? Oops, I stuck that on there. Let's get a regular pen. All the co-functions are negative. What do you notice as we go from left to right? Sine, cosine, secant, cosecant, tangent, cotangent. They all seem about the same. So if you can remember sine, secant, and tangent, the derivatives, the arc ones of those, you'll get the cos almost for free. You just need a negative sign in the front. Okay, so it's about the pattern. So if we notice that we want to take the arc sine or whatever it is, we just fill the pattern in. Okay. So if we're looking for the derivative of the arc sine of 2x, okay, if you remember, that's the u primed equals u primed over the square root of 1 minus u squared. It's the form that we take. In this case, u is equal to 2x. So we just fill in the pattern, the derivative of the arc sine. The u primed derivative of 2x is 2. And then on the bottom we have the square root, oh, that's awful, of 1 minus 2x quantity squared, which we would probably rewrite as 2 over the square root of, that's better, 1 minus 4x squared. Okay, and then that's it. We know the pattern, we know what we're aiming for, we just figure out what u is, u primed over 1 minus u squared, square root of that. Okay, that's the derivative of the arc sine. Derivative of the arctan, that's u primed over 1 plus u squared. So in this case, u is equal to 3x. Okay, and I'm quick to recall these because I've been working with them for a while. You'll get them into your brain. You'll want to get them into your brain before the AP exam. But for now, you have them on the cards. So just say, oh, it's arctan. Let me make the thing fit. Okay, so u primed, the derivative of 3x, is 3. And then we just do 1 plus 3x quantity squared. And we'd probably rewrite that as 3 over 1 plus 9 squared. Okay? And there you have it. And finally, maybe finally, the derivative of the arc secant of e to the sine 3x squared plus 5. See how that works? Okay, so arc secant is the one that's a little different. We've got u primed over the absolute value of u times the square root of u squared minus 1. Okay? With the arc secant, the u's are right next to each other. With the arc sine, it's the 1 minus the u. It's just things that might help you remember. And so, as we turn this out, one thing we're going to do is, well, what's u? U is going to be e to the sine 3x squared plus 5. And the hard part is going to be what's u primed. So u primed, we know the derivative of e to the something is still e to the something. And then we've got to do the derivative of the argument. And so we've got to do the derivative of the sine, which is the cosine. And then chain rule says derivative of the argument, which is that. So it's this times this times this. So when we write u primed, I'm going to put 6x out in front. And then I'll probably put cosine of 3x squared plus 5, and then I'll probably put the e to the sine 3x squared plus 5, and then it's just a matter of, absolute value of e to the sine 3x squared plus 5. Little lousy e. Let's see if we can fix that. times the square root of e to the sine 3x squared plus 5 squared, and the squared is just going to make it 2 times that, okay, minus 1. There you are. It's ugly, but works out okay. And then it turns out that, well, it can't really cancel because this is within the absolute value, so we don't want to get in the habit of canceling. They look like they're the same terms, and they may work each other out, but if we cancel them, we lose the possibility that, we'll lose a negative sign along the way. So we just do it as this over the absolute value, and it's just going to keep track of whether it's positive or negative. Okay, so one problem, I can check a bunch of things. Do you still know how to do the derivative of e? Do you still know how to do the derivative of sine? Do you still remember the chain rule, all in one problem, and then it's just writing it over, okay? And there's that, and that, and that. And so we'll go back to the first page, or this page here. You'll get so you sort of recognize these, but again, they're patterns. They fit the pattern. You make it work. You look it out, look at it, look it over, and you write it down, okay? I think that's it. 6 minutes and 11 seconds, and 30 of it was me just waiting for you to think. Okay, so see you tomorrow. Get questions, you ask. You know the story. Thanks for watching. Hope you learned something. See ya.